Hi, Professor Ozioma Adong-Ekpete. Welcome my viewers and students to this class this morning. And I am excited to deliver this lecture. Today, we'll be looking at sample preparation through ashing. Don't forget to subscribe, like, comment, and share this video. In our last class, we talked about sampling. We talked about homogeneous sampling, heterogeneous sampling, sampling of solid, sampling of liquid, and sampling of gases. If you were not part of that class, don't fail to go back and watch that video. At the end of this class, I expect my students should be able to describe what is ashing, contrast the difference between the types of ashing, and state the materials used for ashing. Before you ash, you prepare your material. Sample preparation is the way a sample is prepared prior to analysis. Samples may be dissolved, solid samples may be dissolved in water, or digested in acids and then filtered to remove insoluble components. Compounds that will interfere with analysis must be removed or masked during sample preparation. And sample preparation may involve dissolution, filtration, extraction, reaction with some chemicals, pulverizing, treating with a chelating agent, masking, filtering, dilution, etc. What is ashing? Ashing is that process whereby a sample is burned, in a morpho furnace or treated with acids to get the mineral composition of that sample. An ashing technique is very important in analytical chemistry. Ash content represents the total mineral content in food, and it is part of proximate analysis for nutritional evaluation. Ashing is the first step in preparing food sample for specific elemental analysis. Ash is an inorganic residue that remains after the removal of water and organic matter. And there are two major processes we can use in this ash analysis technique. We use dry ashing and wet ashing, though we also have sulfated ashing, as we will learn in the process of this class. The key difference between dry ashing and wet ashing digestion is that the dry ashing process involves the dry state of the sample. The sample is in dry state, while in wet digestion process, the sample is in aqueous state. What is dry ashing of samples? In dry ashing, the sample is ashed in a dry state, using what we call a morpho furnace. This sample is placed in an inert vessel and the combustible organic portion is destroyed by thermal decomposition using a morpho furnace at a temperature of 450 to 600 degrees Celsius. The inorganic matter that remains is not determined. Oxidizing agents such as nitric acid and magnesium nitrate can be used to fasten this process because the dry ashing process normally takes time. It can take up to 12 hours. It can take up to 14 hours. It takes time. And for this dry ashing process, the mineral present in the samples are converted into sulfate, phosphates, or chlorides and silicates. By the addition of sulfuric acid, we can convert them, because we don't want these minerals. Some of them are very, very volatile and they can be lost in the process of ashing, such as copper, lead, mercury, nickel, zinc, etc. So they are converted to their lead chloride salt, cadmium chloride salt, and sodium chloride to non-volatile silicates. And we can also have the loss of anions such as arsenic, phosphorus, boron can be prevented by the addition of alkali metal carbonates, We can add magnesium acetate and alkali earth metal nitrates. Dry ashing can be applied to mineralization of organic materials such as biological tissues, liquid plants and foodstuffs, sludges, etc. It is that analytical process that the composition of a sample is determined in the dry state. The basic process is to convert the organic component into fumes and measure the weight of leftover ash. In dry ashing, water and other volatile materials are vaporized. We have to find the weight of the sample before the ash. Always note that before you ash, you find the weight of your sample, and then after ashing, you also find the weight of your sample, and then your ash content now you can be determined by the measurement of your ash, of the weight of the ash over the weight of the dry in percentage. And the ashing containers used could be the quartz, the pyrex, the porcelain, the steel, and platinum. Always find out the right ashing container that you will use in sampling your materials. We know that most dry samples like whole grain, cereals, and dry vegetables need no preparation, but fresh vegetables need to be dried prior to ashing. And high-fat products such as meat may need to be dried and the fat extracted before ashing. That should be noted. There are sources of error in dry ashing, and this could be as a result of the analytes reacting with the crucible material. And the extent of losses depend on the temperature, the crucible, the chemical composition, and the sample. Silicates, phosphates, and oxides, for example, can react with the crucible porcelain enamel, and it is advisable to use crucible made of quartz or platinum. Always note that you must find the right crucible for the drying of your material to avoid errors. The advantages of this dry ashing is that few reagents are needed and simple apparatus are needed, and it requires limited attention. You can dry ash and still be busy doing other things. But the disadvantage is that it takes too much time. And to overcome this challenge, the microwave assisted ashing was introduced. This takes just few time during that process. What is wet ashing? Wet ashing is the process of oxidative decomposition of organic samples by liquid oxidizing reagents such as nitric acid, hydrochloric acid, sulfuric acid, and perchloric acid, or mixtures of acids. Wet ashing converts the organic sample to carbon dioxide and water. It is carried out in a closed vessel to avoid loss of halogen, sulfur, and nitrogen. Wet ashing breaks down and removes the organic matrix surrounding the mineral so that they are left in an aqueous solution. It's a very, very useful method of ashing. We always have what we call the aqua regia. Most times students will use it, which is a mixture of hydrochloric acid and nitric acid in a ratio of 3:1. We can also have mixtures of nitric and perchloric acid, but special care is needed when we are dealing with perchloric acid. Concentrated perchloric acid alone is dangerous and explosive, so always note that you should use it in a special hood. In wet ashing, all mineral oxides are formed, and the sample is in aqueous solution process. Digestion flasks are used. Heating temperature may be below 350 degrees for a few minutes or hours. The advantage is that little loss of volatile material is involved and low sample throughput, and is less hazardous. It is important to state that there are also some other types of ashing, such as sulfated ashing, closed system ashing, low temperature ashing. Sulfated ashing is that ashing treatment which involves the treatment of the sample after charring using an open flame with sulfuric acid, and then you place in a muffled furnace. We have the closed system ashing that involves thermal decomposition of oxygen in a closed system, such as a Schoeninger flask or an oxygen bar pump. And we also have the low temperature ashing, where we ash samples at a temperature lower than 120 degrees using activated oxygen. The employment of such low temperature was necessary for the determination of volatile elements as mercury, arsenic, and selenium. What are the uses of these acids in ashing? I want to state here that nitric acid is added to water sample to ensure that metals are dissolved. If it is not added, some metals, including iron, may oxidize or form oxide, mineral precipitates, and then not be detected in the chemical analysis of the water, especially when you're dealing with water analysis. And then for some material, sulfuric acid is added before you heat to facilitate the destruction of organic material and to fix certain metals as their sulfate salts to prevent volatilization, which I already said that some of these metals will volatilize when you ash them. So a simple addition of sulfuric acid, will prevent it. And sulfuric acid does not produce corrosive, irritating vapors to the extent of hydrochloric and nitric acid, and it's not a powerful oxidizing agent compared to nitric acid. It makes it less of fire hazard, so you are not afraid that there will be fire at the end. That is why for some materials they use this sulfuric acid. In wet digestion methods of plant sample analysis, perchloric acid is always added to prevent excessive frothing, which occurs when we use nitric acid or sulfuric acid. So that's why we have different acids that we use in different analysis. What's the difference between dry and wet ashing? We just want to state three differences here. We know that in the dry ashing method, the samples are ashed in dry state, while in the wet ashing method, samples are ashed in aqueous state. And then temperature, we heat at high temperature for the dry ashing, temperatures of 450 to 600 degrees centigrade. And then we heat at low temperature below 350 degrees Celsius for wet ashing. Organic matter are burned to form water vapor, nitrogen gas, and water. Volatile matter are vaporized. And then that is for dry ashing. And then for wet ashing, organic matter are decomposed and removed from the sample as mineral oxides are formed. These are the major differences. Don't forget to subscribe, like, comment, and share this video. In the next class, we'll be treating statistical treatment of data. Thank you.